Okay, the next talk will be given by Marij van Strien. Let's welcome her on Bohm's theory of quantum mechanics and the notion of classicality. Thank you very much.
Yeah, thank you. So I will talk about Bohm's theory of quantum mechanics. I will not have time to give a proper introduction. I will just say a few things. So this is a theory that he proposed in 1952, which offers an alternative approach to quantum mechanics, or a rival approach to establish theory of quantum mechanics at that time, but one which is empirically equivalent to orthodox quantum mechanics. And what is particular about it is that particles have a well-defined position at all times, and it's a deterministic theory, so you can exactly follow the trajectory of each particle. So this theory has often been seen somehow as a return to classical ideals in physics, such as, or in particular, determinism, mechanism, and realism. So in presenting a theory where you can follow the trajectory of each particles, it's often seen as a return to classical physics, and somehow both by opponents have criticized it as an artificial attempt to return to an outdated worldview, while adherents of Bohm's approach to quantum mechanics have used it to argue that there can be a completely straightforward, common sense account of quantum mechanics without all the weird things that are commonly associated with quantum mechanics. So quantum mechanics can be fully understood. There's no weird things with observations. There's no, it's also used against speculative or mysticist uses of quantum physics. So in both the opponents and adherents, you can find this idea that this is a way to do quantum mechanics in kind of a straightforward classical manner. Then it's kind of interesting that Bohm himself drew very speculative or even mystical implications from his theory. Or he was very interested in his later years in Eastern mysticism, and connected this also to his theory of quantum mechanics. That's a kind of curious situation. So, how to explain this situation, that the same person who is known for having a very straightforward classical approach to quantum mechanics is also someone who, formulated very speculative ideas about quantum mechanics. So you may think that this is simply a question of early Bohm versus a late Bohm. That, sometimes when people get older, they tend to develop some more, some weird ideas. So that may just be a case of that, so to say. I argue that this is not the case. I will argue that there's actually quite a lot of continuity in his thought. So my aim in this talk is to look at Bohm's philosophy of science, and show that there's actually a lot of continuity in his philosophical commitments. So first about reaction to Bohm's theory. So here are some examples. Heisenberg, when speaking about Bohm's theory, says, well, we see how difficult it is when we try to push new ideas into an old system of concepts belonging to an earlier philosophy, or to use an old metaphor when we attempt to put new wine into old bottles. Or Pauli writes in a letter that to dream of a way back to the classical style of Newton, Maxwell, seems to me without hope, devious, of bad taste. So this reaction, of Bohm's theory fits in a larger pattern, I think, where in this period there was a tendency to see all opposition to quantum mechanics as a refusal to accept the past quantum revolution. So also for Einstein and Schrödinger, for example, it has been argued that their criticism of quantum mechanics was very much understood as an attachment to classical physics or to determinism. Well, actually it has been argued that their actual concerns went deeper than that. So I think, yeah, this criticism of Bohm fits in a larger pattern. Bohm very much himself rejected this idea that his ideas were somehow conservative. So he emphasized, for example, how determinism or restoring determinism was never the main issue. So already in 1954, he distanced himself from a view of absolute determinism and included fluctuations in his model. He also emphasized that his aim was really not to make a philosophical point about physics, but really to, his aim was progress in physics. So, for example, in his book from 1957, he argues that physics is in a state of crisis, in particular because of the issue of compatibility between quantum mechanics and relativity theory, and also so-called fundamental particles seem to be falling apart and even in more and more particles. And he argues this state of crisis, so to say, calls for a new revolution, calls for a radically new approach. So that's what he's trying to do, and he emphasized that what is needed is conceptual change in physics. And he also argues that science is open-ended. We will never arrive at a fundamental level. We'll never arrive at any law of physics that holds absolutely. There's always going to be deeper levels and further developments. So in his 1957 book, he even turned the accusation around and accused his opponents of being attached to classical ideals. So here he sees classical mechanics as being characterized by an assumption that physics has arrived at fundamental laws that hold absolutely and will not be changed in future scientific developments. And he says, well, that's what his opponents are doing. They are taking the current theory of quantum mechanics to hold absolutely, to be a final theory. That's what makes them actually the real classical mechanists. So you may think that all of this is just a rhetoric, that he is accused of being conservative, so he emphasizes how progressive he is. Nevertheless, I don't think it's mere rhetoric, because I think if you look at his philosophical commitments, his main aim seems to be to derive at an intuitive understanding of quantum mechanics, of quantum processes. Well, maybe you could argue that this in itself is a classical ideal, to aim to understand something, but he always emphasizes how physicists should try to arrive at new ways of understanding, and especially how they should try to develop new concepts. And from the beginning, he was very much committed to holism and the idea of interconnectedness of everything, and also to this idea of the unlimited complexity of nature. So I think these are his central philosophical commitments, and most of them can already be found in this textbook of quantum mechanics that he published in 1951, and basically remains, so before even introducing his alternative approach to quantum mechanics, and remains basically constant throughout the years. And furthermore, Bohm argued very strongly for a pluralism in science, arguing explicitly that, well, developing alternatives to a theory, even if you have a very well-established theory, it's still desirable to try to develop alternatives, or alternative theories, alternative conceptual frameworks. And this is even required for properly testing the theory. So in the paper of 1966, Bohm and his co-author Bob argued that if no attempt at developing alternatives is made, this might lead to our being trapped in a given set of concepts without even realizing that we are thus trapped. And so I have argued elsewhere that Bohm and his approach to quantum mechanics was really influential for the development of the philosophy of science of Paul Feyerabend in two different ways. First, so yeah, I have to say before, Bohm and Feyerabend were colleagues in Bristol for a while in 1957, 1958. During this time, they had lots of discussions about physics and philosophy. And I think that this is crucial for the development of Feyerabend's pluralist philosophy of science in two ways. Namely, first, he came to see quantum mechanics as an area in which pluralism is badly needed, because he came to be convinced that, yeah, Bohm's alternative approach, so to say, was dogmatically excluded by the community of quantum physicists. And second, in a few footnotes and acknowledgements to his publications, Feyerabend has acknowledged Bohm for also his arguments for pluralism. It says that he developed this pluralism, these arguments in discussions with Bohm. And yeah, for Feyerabend, this is also central in his disagreement with Thomas Kuhn. So this is a letter that Feyerabend wrote to Kuhn in 1961, that Feyerabend had read a draft of Kuhn's Structure of Scientific Revolutions and wrote a very critical letter to Kuhn about it, and writes, among others, that your insistence upon faithfulness to one and only one paradigm is bound to result in the elimination of otherwise very important tests, and it is bound in this way to reduce the empirical content of the paradigm you want to be accepted. It may well be, and Bohm and Vijay are definitely of this opinion, that the situation is the same in the present quantum theory. Well, Bohm himself was, at least in first instance, more positive about Kuhn's Structure of Scientific Revolutions. He wrote a review about it, saying that this is without a doubt one of the most interesting and significant contributions that has been made in recent years in the field of the history and philosophy of science. But what Bohm concludes from Kuhn's book is basically that it's really important to be aware of the role of paradigms in science in order to avoid dogmatism, so to be, yeah, independent from the prejudices that of your time, so to speak. And as he wrote later in a book on creativity that he wrote together with Pete in 1987, they write that a paradigm tends to interfere with that free play of the mind that is essential for creativity. So for Bohm, this is, yeah, the lesson from Kuhn, is try to be free of, yeah, the conventions and the assumptions of your time. So in this book on creativity, Bohm and Pete, so they argue scientists should be more open to change their preconceptions and to pursue new ideas, and argue that this would lead to a pluralism of theories. And at any given moment, there would be a number of alternative points of views and theories available in each particular area of science. Traditionally, scientists have assumed that when several theories appear to account for the same phenomenon, then only one of them can be correct. There is no logical reason, however, why, in the unfolding of scientific ideas, several theories may not offer alternative, but equally valid and important accounts of a particular aspect of nature. So, with that, I come to the question of, was Bohm actually a realist? So his approach to quantum mechanics has often been characterized also as primarily trying to offer a realist account of quantum phenomena, where you have, real particles moving around, and you can see exactly what's going on. I would say, the main motivation of his theory was, to develop an ontological account of quantum processes. But Bohm, insists in various places that he doesn't take scientific theories to offer true descriptions of reality or even approximately true descriptions of reality. Although the theories get something right, he just doesn't see the sense of requiring theories to be true descriptions of reality. Writing that the ultimate reality is unlimited and unknown, but its successive appearances serve as an ever more accurate guide to coherent action in relation to this reality. Furthermore, as just seen in the previous quote, he also allowed for there being several equally valid theories describing the same phenomena. And also then, perhaps most surprisingly, he argues that science does not actually deal with an independent reality. And this has to do with his views on measurement. So also Bohm's theory is often seen primarily as a way to solve the measurement problem in quantum mechanics. But then it's quite remarkable that Bohm actually doesn't speak much about measurement. So Oliver Freire talked this morning about when did the measurement problem actually become a problem, and argued that this is during the 1960s that this really emerged as a problem in quantum foundations. In his text from the 1950s until the 1970s, Bohm actually says very little about the issue of measurement. Then in the 1980s, he speaks more about measurement, but then he argues that his theory of quantum mechanics shows that measurement do actually not reveal intrinsic properties of the system under observation. And this is because for all variables other than position, measurement outcomes will depend on the entire experimental setting as a whole. And in contemporary Bohmian mechanics, it's concluded from this that position is actually the only property that particles really have. And other quantum variables do not really refer to actual properties. But Bohm seems to regard position more as an exception and argues that generally measurements do not reveal intrinsic properties in his theory, with position as an exception. So this fits with his holism, with his continuous, continuing attachments to the idea that everything is interconnected, in this case showing that there is no strict separation between the observer and the observed. So, concluding from this that science does deal with an externally existing reality, but not with a reality that is independent from us. Bohm's interpretation of quantum mechanics, as I said in the beginning, has been used to argue against the idea that quantum mechanics has all these weird implications. So also the few authors who have really engaged with postmodern uses of quantum mechanics tend to appeal to Bohm to argue, well, see, quantum mechanics doesn't have to have all these implications. And in a paper, Beller, in a paper that David Kaiser also briefly mentioned yesterday, argues that, well, if physicists would have declared that Bohmian mechanics is a respectable interpretation of quantum mechanics, this could have diminished greatly the explosive proliferation of the postmodern academic nonsense connected to quantum mechanics. We already maybe have seen that this using Bohmian mechanics to criticize the idea that quantum mechanics has weird implications is problematic. But then I found that Bohm actually, in 1988, published a paper explicitly arguing that we need a postmodern science. and arguing, for example, that it's a mistake to think that the world has a totally defined existence separate from our own, because we are enfolded inseparably in the world with no ultimate division between matter and consciousness. Meaning and value are as much integral aspects of the world as they are of us. Postmodern science must therefore overcome the separation between truth and virtue, value and fact, ethics and practical necessity. So yeah, I don't think that Bohm can really properly be called a postmodern thinker, but well, he does explicitly argue for postmodernism, so to say. And I found another, yeah, you can also find people who write about this physics postmodernists who write about physics, so to say, actually also refer to Bohm's writings. Yeah, so to conclude, I've argued that Bohm never was a conservative thinker, never tried to get back to the classical world, and always, in various ways was a progressive thinker. So you may take this to show that, some of the criticism he received is unjustified, that when he first published his theory, when it was criticized for being conservative and reactionary, this was an unjustified criticism. But also, I think this points attention to the fact that Bohm's theory really doesn't restore classicality, and Bohm is a dubious hero for those who want to argue that quantum mechanics doesn't have any weird implications. And maybe it also shows that Bohmian mechanics doesn't have to be connected with a strongly realist program, that the aim to develop a clear understanding of what is going on with quantum processes, which was ultimately Bohm's central aim, doesn't have to be connected with the aim to develop a theory of reality as it really is, so to say. Thank you.
So thank you for the new perspective on Bohm. So I already see a question.
First, I want to congratulate you with the wonderful talk you give us. I have been studying the last few years Bohm's work in order to write this biography, and it's my impression that you grasped much of the complexity of Bohm's ways of thinking. So, congratulations. The only comment or the only distance I would take from your talk is that Bohm thought about the meaning of quantum mechanics during 40 years, each month, each day, trying to understand the quantum mechanics, from 1950, 1951, till the last of his days. So we should suspect a little bit that he was fully consistent through these 40 years. If you take Niels Bohr, he was not fully consistent. There were some tensions. So the image you presented of continuity, I agree that there is much continuity than one would expect. But I think that there were some changes of emphasis.
Yeah.
And I'd like to highlight two changes of emphasis. It's true that Bohm in 1952, he did not like restoring classical determinism. But it is meaningful that while the word determinism or causal interpretation did not appear in the 1952 papers, immediately physicists began to call causal interpretation, and Bohm was the first to use causal interpretation throughout all the papers in the 1950s. And Bohm's main collaborator in the 50s, it was Jean-Pierre Vigier. Jean-Pierre Vigier was a strong advocate of determinism for ideological reasons. So, if you take Bohm's later writing, he says determinism was no the main issues, as you said. But I would say that he was not very emphatic about this when the interpretation appeared. So he did not take distance at that moment. And at that moment in the 50s, causal interpretation and the restoration of determinism were understood as the same thing by physicists. And the second, it's true that holism is an element of continuity, but I think that holism was more implicit in the 1952 paper, was not so valued as Bohm valued in the end of his days. Now, my conjecture to explain this change, one of the things is that Bohm's attachment to causal interpretation, to determinism, was run in parallel to his Marxist commitments. And he broke up these commitments around 1956-57. There is a nice discussion in his correspondence with Charles Biederman. This is highlighted in a book, Paul Buchanan, published, where this change of mind of Bohm about causality and determinism is well highlighted. But again, thank you very much for the wonderful talk.
Thank you. Yeah, I think you're right, of course, that to say that everything that his philosophical commitments were continuous throughout his 40 years can only be a simplification. Of course, some things changed, but I was surprised how much continuity there was. About determinism, yeah, you're right that he used this term causal interpretation, but then I'm a bit unsure about what exactly he means by causal, because causal is a tricky word. It can mean determinism, but it doesn't have to mean determinism. And yeah, I doubt especially whether he was ever really that attached to determinism, because already in his 1951 textbook he has a section on determinism saying that it was never more than a historical prejudice or something like that. And already then in his 1954 paper with Vigier adds fluctuations or argues that the wave function arises from underlying fluctuations. So there seems to be then only a very short period that he really argued for straightforward determinism. But yeah, I would like to talk more with you about this.
So, Michael, this paper by Vigier is very important because they introduced random fluctuation, but it was noticeable that the title of the paper is still causal interpretation.
Yeah.
And my analysis that for physicists in the 50s, causal interpretation and determinism was similar. Not classical determinism in the sense that part of restoration of classical mechanics. It's true that Bohm never thought to come back to classical mechanics. But I think that he hoped to restore causal and determinism in quantum mechanics, at least in the beginning of the 50s. Then later he changed his mind.
Yeah, thanks very much for the beautiful talk. I in fact work also in the same direction. I have a paper called Historical Misconception or something, where I claim also that Bohm was never attached to determinism, in fact. And I think you're also right, Olival, in the sense that for the physicists, so it was in fact a misconception of the community to identify the causal interpretation with the strict determinism that historically was conducted was upheld in the interpretation of physical theories. I think that Bohm never really meant by determinism, causal interpretation, never identified really causal interpretation and determinism. I think that he conceived causal, the mere possibility of having a cause-effect relation, which could be looser than strict determinism. It could be an objective propensity, for instance, that is causally relating events, but is not bounded to have a single outcome given the same set of causes. And he makes explicit this in his late years when he writes, where he interacts with Popper, for instance, where he writes that his paper with Jean-Pierre Vigier in 1954, this quantum fluctuation could be interpreted as guided by a quantum potential, which is nothing else than a field of propensity. He writes explicitly this to Popper. So I think that is mostly the reading of the community of physicists around Bohm, also the supporters of Bohm. I think that they kind of misinterpreted his original thoughts, and he was never wedded to strict determinism. But I agree that he was always interpreted like this. So in the historiography has been portrayed like this.
So do you want to answer another remark?
No, thank you.
Okay, then that's a very good final word on Bohm, I think. Now we have a half an hour of a coffee break. So now it's coffee and snacks downstairs.